Welcome to The Explainer. Today we're going to crack open the mind of a robot. And, what we find inside is this constant tug of war. It's the split-second gut reactions fighting against that deep, careful planning. So let's break down this whole dual brain idea and see how modern machines actually think.
So here's the fundamental problem, right? Think about a self-driving car that suddenly sees an obstacle, or a factory arm that needs to grab a super delicate object. How does it make that critical decision in a fraction of a second? It has to be incredibly fast to be safe, but it also has to be incredibly smart to understand our messy, unpredictable world. And that's the real puzzle we're digging into today.
Okay, before we dive any deeper, let's get one key term out of the way. ML inference. I know, it sounds super technical, but it's really not. Just think of it as the moment a robot uses all its AI training, looks at what its cameras and sensors are seeing right now, and then makes a call. That's it. Inference is basically the robot's brain in action. So how do robots actually solve this whole speed versus smarts problem? Well, the first approach is all about pure raw speed. We're calling it the reflex, but its technical name is edge inference.
So what exactly is edge inference? You know what? Think of it just like your own reflexes. When you touch a hot stove, you don't stop and think, send a message all the way to your brain, wait for a detailed analysis, and then pull your hand back, right? No way. The reaction is instant, happening right there at the source. That is edge inference for a robot. All the thinking happens right on the machine, on its own little onboard computer. Zero delay. And this reflex approach has some massive advantages. Reliability, for one, means it works even if the Wi-Fi dies, which is absolutely critical on a chaotic factory floor. And data privacy is a huge one. Sensitive camera data never even has to leave the robot itself. Plus, it's super efficient, so it doesn't clog up any networks. It's like a self-contained little powerhouse.
But out of all these perks, low latency or just, response time is the absolute game changer. We are talking 10 to 50 milliseconds. That is literally faster than you can blink. For a robot that's trying to avoid a collision, that kind of speed isn't just a nice little bonus feature, it is an absolute necessity.
Of course nothing's perfect, right? This incredible speed comes with a pretty big trade-off. The robot's onboard brain is limited by its physical size and how much power it can slurp up. You just can't cram a giant supercomputer into a small delivery drone. And this limitation forces it to run smaller, simpler AI models, which, might not be quite as sharp or as nuanced as the really big, powerful ones.
So, if the edge is the reflex, what's the alternative? Well, let's move on to our second contender, the one that prioritizes raw intelligence and deep, careful thought. Meet the strategist, also known as cloud inference.
The idea here is basically the complete opposite of the edge. Instead of doing the thinking itself, the robot sends its sensor data, all the stuff its eyes and ears are picking up to these massive, powerful data centers in the cloud. It's kind of like the robot is phoning a friend, who just happens to be a global network of supercomputers. All the heavy lifting, all the hard thinking, happens remotely.
And the benefits here are just huge. First up, high computational power. By tapping into the cloud, a robot gets access to almost unlimited processing power. That means it can use the most complex, the most accurate AI models out there. And second, for a company that's running a whole fleet of these things, centralized management is a total game changer. They can update and manage every single robot from one single place.
So we have a classic trade-off here. It's a real dilemma in the world of robotics. On one side, you've got the edge. That's the fast, low-power reflex that works even when it's offline. And on the other, you've got the cloud, the incredibly smart, high-power strategist that absolutely needs an internet connection. It's speed versus power, reflex versus intellect.
But what if a robot didn't have to choose? What if it could have both the lightning-fast reflex and the deep-thinking strategist? Well, this brings us to the ultimate solution, the really elegant approach that's used in most of the advanced robotic systems today. The answer, as it turns out, isn't either or, it's both and. The most practical, and frankly, the most powerful approach is a hybrid model that takes the lightning-fast strengths of the edge and combines them with the massive intelligence of the cloud. So here's how it works in practice. Step 1. The robot uses its local edge brain for instant actions, like slamming on the brakes before it hits a wall. Step 2. At the exact same time, it's uploading data about that whole event to the cloud. Step 3. The cloud then does the heavy analysis, figuring out, why do we almost hit that wall? And finally, step 4, it sends an improved, smarter AI model back down to the robot's edge brain. It's this continuous loop of acting, learning, and getting better.
So this constant conversation between the edge and the cloud, it's more than just clever engineering. It is a genuine breakthrough. This balanced approach is what truly unlocks the potential of robotics in the real world. Let's look at how.
This hybrid architecture is really the secret sauce behind the most advanced robotics out there. We're talking about autonomous vehicles that need to react instantly, but also have to plan these long, complex routes. We see it in smart warehouses, where entire fleets of robots coordinate perfectly, and in advanced factories that can actually predict when a machine needs maintenance before it even breaks down.
And this quote from our source material really just says it all, doesn't it? The key takeaway here is that this hybrid model achieves the best balance. It gives you that instant, real-time responsiveness that you need for safety, while also providing the computational muscle you need for truly complex intelligence. It's the reflex and the strategist working in perfect harmony.
And you know, that leaves us with a really fascinating final thought to chew on. As our world gets more and more connected, with faster networks like 5G and whatever comes next, is that balance going to shift? Will a robot's brain start to live more in the cloud? Or will the computers inside its own body become so powerful that the cloud becomes less necessary? It's a question about where intelligence itself will ultimately end up living.